We are walking plastic factories. It's an unfortunate fact of modern life. On average, people consume or inhale about 80,000 particles of plastic a year. Most of those leave your body, which is good. But the ones that stick around are the ones that are really, really small. When I first started this research, it was a race to find out where plastics were not. But unfortunately, we've yet to find any environment that is free of plastics. So now we've progressed in our thinking to not a race to find a clean space and protect it, but to better understand how plastics are actually migrating to all of these different places, even when they are so remote. So when I first started this project, we wanted to better understand microplastic contamination in our local environment, in our own backyard. What are the plastics in Utah Lake? How are they building up? And in the progression of our studies, we found that those microplastics are present not just in Utah Lake. They're in the sediments, they're in the air around us, they're in the snow and the rain. And so that's forced us to really expand where we've been looking in our own backyard. So we have a wonderful partnership with the National Park Service where we have a research permit to look at microplastics in Timpanogos Cave. One of the concerns is that the minerals in the water of that cave become incorporated into the geological structures of the cave. And when you have plastics present, they can actually integrate into the structures of the stalactites and the stalagmites. And that means that we are forming rock that is then contaminated by plastic particles, and that will have a really long-term impact on geology. So I love having students involved in this project because it really connects students with the world of science and its applications. They're able to see what they've learned in the classroom, apply it in the field, and they're able to actually see a connection with their own backyard. They can see the connection between their environmental science and chemistry skills, their consumer habits, and the environment that they live in. Science is an incredible global enterprise, and that's because all of the questions that we really need to answer affect the entire world. So I'm actually a bioinorganic chemist by training, so that's where inorganic chemistry and biochemistry have gotten married together. And I love looking at the science that's actually at the intersection between fields because that's where I find fascinating questions reside. And that's what eventually led me to microplastics because it's environmental science and chemistry working together. So realizing that microplastics are everywhere and that they're unavoidable and that they're long-lasting is definitely something that is challenging to wrap your head around. And it can be hard for researchers and students to come to grips with this. And so one way that we try to bridge that gap between grief to eventually acceptance is to think about the role of scientists. Being a scientist means that you can be a leader to find a solution in this field. So this is not just about identifying challenges and problems and feeling overwhelmed by their magnitude. It's about accepting the challenge, seeing it for what it is, and trying to design solutions, and being part of that solution helps you accept that problem and its magnitude. So students working on microplastics, they get to sample the best of all worlds of science. They get to design scientific questions. They get to build up their knowledge in a very extensive field. They get to go out and do field work. So when I am doing microplastic analysis on lake samples or snow samples, my students are the ones who get to collect all of those samples. And then in the lab, all of the work we do to analyze microplastics involving fluorescent microscopy and spectroscopy is all student-driven and all student-run. Students who work in the lab get to apply science outside the classroom. You learn all these concepts in the classroom, but you don't fully get to understand them until you apply them in the lab, and you get to experience one of my favorite parts of research, not knowing. When you learn something in the classroom, it's known. You do a homework problem, it has a right answer, and someone knows the right answer. But when you do research in the lab, you're trying to answer a question, but you may not find that answer for some time. And it involves trying things, not always succeeding, learning from our failures, and trying again. That's science.